Today is for experiment 2, qualitative analysis of anions. This is a 30 points experiment, 15 points for the lab report and the 15 points for the unknown. I'll explain that later. Objectives for this experiment is to determine the identity of ions in the mixture. So we'll study the chemical and the physical properties of these 6 ions and their reactions. And we will also try to develop a flow chart to separate and identify all 6 ions and in one unknown solution. Here in the pre-lab discussion, I have videos, pictures for you to understand what you should see in the reaction happens. Before we proceed in here, well, I'm hoping that you guys memorize the reactions regarding these ions, especially the ones that would cause a precipitate or gas forming. Okay, you'll see why I want you guys to memorize those reactions. So there are 3 parts for this experiment. One is testing individual anion solutions. Second is to test a mixed anion solution. A flowchart is developed here based on the observations, which are detailed in table 1. You'll see that in the template. And then testing an unknown solution. You will receive an unknown letter shortly after today's discussion. And based on your unknown letter, you will have different observations. And you need to tell me what ions is in your unknown. The first part, testing individual anion solutions. In here, we'll have a few drops of individual anion solutions in these test tubes. And here we make duplicates here for different tests. All 6 anions are in here. The first test is to add a little bit silver nitrate into each individual test tube. And after adding this, there should be participate in some of the test tubes, right? So if you remember what type of anion would react with silver plus, then you can expect a certain reaction will happen in some of the test tubes. For example, if you look at the chloride, iodide, here, they should have a participate, right? If you remember the solubility chart, silver chloride and silver iodide, they are not soluble in water, so you have participates in here. What about carbonate and phosphate? In this case, you can see the sulfate and the nitrate test tube are clear, meaning there's no reaction happened in those 2 anions. So this is a close look of the participate. So there's a silver chloride down in the bottom there, and the silver iodide in there. This is a phosphate, so a yellowish participate, and the carbonate. There's a silver carbonate in the bottom there. So if you memorize the solubility table, by now when you see these reactions, you probably already have the reaction in your mind. And later on, in the lab report, you need to write out the NIEs for all of these reactions. If you don't memorize the solubility table, that's probably okay. It's just going to take you some time. Go back and look for what kind of participate that is in the solubility table. Now, next step is to add nitric acid into those participate. After we add the nitric acid, you can see in the chloride and iodide test tube, the participate is still there. What about the carbonate and the phosphate? After you adding nitric acid, the participate in there disappeared. So next step, we'll add the ammonia to the test tube, and that's not added with nitric acid. So remember, we have duplicates, right? We add a silver nitrate to each of the test tube. and they won't have a participate. We add the nitric acid to one of the test tube, one of the duplicates, and the participate remains there. And for the other test tube, we add ammonia. So you can see for the chloride, the participant disappeared. And for the iodide, the participant is still there. Now, next step is to add nitric acid into the test tube that just added the ammonia. So when we add the nitric acid into that test tube, remember it was clear for this one. And after adding a little bit more nitric acid, the participant appears again. So what do you think happens here in this couple of steps? So silver chloride got dissolved in ammonia because it's forming a complex ion, right? And this complex ion is destroyed when you're adding nitric acid, because the nitric acid is going to react with ammonia that will destroy the complex ion. After the complex ion is destroyed, the silver plus will combine with chloride, again forming silver chloride, which is not soluble in water. The second test is the barium test. So we can add barium acetate to those anions that did not participate. Remember what did not participate? Sulfate and nitrate, right? These two anions. Now we add barium acetate. Now, what's going to happen is in the sulfate anion test tube, we can see participate forming there. Test 3. So let's go back to phosphate and carbonate. When we add a silver nitrate, there's a white participate in both phosphate and carbonate, right? And then we add nitric acid. The participant disappeared in both of the test tubes. For the carbonate test tube, we are also supposed to see some gas forming there. However, because the concentration is not very high, there's a possibility you won't see any gas bubbles. So if you take a really close look, you should see a little bit air bubbles in there. If it's a phosphate, because that there is no gas forming in there, so you shouldn't see air bubbles. However, this is very difficult to see. So we are using an additional test to identify either it's a carbonate or phosphate ions. So we add sulfuric acid into those two test tubes, phosphate and carbonate, and definitely the white participant should be dissolved. In your lab procedure, you can find the next step is to add molybdate. In the phosphate test tube, the molybdate will show up a light yellow color. That will tell you the phosphate is in there. And for the nitrate, you won't see that color. For nitrate, however, we have a different test. We have a special nitrate test that's also in your lab procedure. And in that test, you should see a brown ring forming in the test tube. It's very similar to iodide forming. So if you do add the same reagent to the iodide solution, you will also see brown forming, but the difference is so the brown ring is a liquid in the nitrate solution. For the iodide solution, you'll probably see some iodide forming on top of the solution. So that's condensation of iodine in there. These two colors are too close. In your unknown sample, if there is a nitrate in it, it won't have iodine. If there's iodine, it won't have nitrate. We won't have these two in the same unknown at the same time. Okay. So there is a technique. It's called centrifugation to separate the participate from the solution. I have few minutes video on Canvas. So after the class, you guys can go there, click on the video, and take a look at the centrifugation process. So this is a lot. All chemical tests are summarized on the next slide, also on the template that you will download. So we have 4 different tests. This is silver nitrate and the barium test. And then the sulfuric acid is added. And then there's a special test, molybdenate test, and the nitrate test. All the observations are listed in that table. Second part of the experiment, we need to develop a flow chart to analyze a mixed solution. Remember, in the first part that we have these 6 ions in individual test tubes. And in this case, we're going to mix all these ions together in one test tube. And we are develop our flow chart to find out what ions in there. For example, if we are adding silver nitrate, some of the ion will react with silver and form participate. So we'll write every solid on the left and every aqueous solution on the right. This solid is going to be silver chloride, silver iodide, silver carbonate, and silver phosphate, followed by another reagent, either barium test or nitric acid is added, and let's see what participate should remain and what should dissolve. And the dissolved is aqueous solution, the aqueous on the right, and the solid on the left. Let's just keep doing that to develop a complete scheme to analyze all the ions in the solution. And also in the lab report, you need to write down all the net ionic reactions for each participate or gas forming. Part of these flowcharts is developed, but it's not complete yet. You need to develop a full flowchart based on the reactions you would expect to happen and observations you would expect to see. The third part is to test an unknown solution. In this solution, you might have 1 or more ions in a mix. And as I mentioned before, it won't have nitrate and iodide at the same time. And you will be assigned this unknown letter shortly after the class. You will receive a message from Canvas. There'll be just unknown number A or unknown number B. In your lab report template, you will have observations similar like that. So if it's unknown A, then this is what you're going to see in the experiment. And then based on the observations, you need to figure out what ions in unknown A. On Canvas, lab report template is provided with all the observations. And there's also an experimental procedure you can follow what's down in the lab. A section of the flow chart is developed, but you need to develop the rest of the flow chart and include it in the lab report. You will need to download the lab report template and create a flow chart, type all the net ionic equations in the places provided, determine the ions in your unknown. There is space for you to type a summary statement and answer some questions in the lab report.